Ever found yourself staring at the sky, pondering why the Earth's orbit is elliptical and not circular? It's a fascinating question, one that takes us billions of years back in time to the very formation of our solar system. You see, the Earth's orbit isn't perfectly circular. It's slightly elliptical, and the reason for this lies in the delicate balance between the sun's gravity and Earth's initial momentum. This momentum was a remnant, a leftover from the swirling cloud of gas and dust that came together to form our solar system. So why isn't it a perfect circle? Well, a perfectly circular orbit would have required a very specific starting momentum, a momentum that our Earth didn't quite have. You might be surprised to learn that Earth's orbit is more like throwing a ball than you might think. Remember the last time you threw a ball? You might not have realized it, but you were demonstrating a basic principle of physics. When you throw a ball, you give it an initial velocity. If you throw it straight up, gravity pulls it back down. But add some forward motion and that ball will keep moving forward as it falls. This is essentially how the Earth's orbit works. Now let's imagine the sun as a giant magnet and the Earth as a tiny metal ball. The sun's gravity is constantly pulling Earth towards it. However, Earth, just like the ball you threw, has momentum from its initial velocity. This momentum propels Earth forward, preventing it from falling straight into the sun. But why isn't Earth's orbit perfectly circular? Well, a perfectly circular orbit would have required an incredibly specific starting momentum. Too little, and Earth would have been drawn straight into the sun. Too much, and Earth would have shot off into the vastness of space. Thankfully, Earth's initial momentum landed in a sweet spot, not too much and not too little. This resulted in a slightly elliptical or oval-shaped orbit. It's like throwing a ball in a forward arc rather than straight up or straight ahead. Most objects in our solar system, including other planets and asteroids, also follow elliptical orbits. A perfect circle is simply a special case of an ellipse, one where the two foci coincide and the ellipse becomes a circle. So, if Earth's momentum had been just a bit weaker or stronger, our planet could have ended up in a very different place. Now here's the kicker, Earth isn't unique in its elliptical journey. It's not just our own planet that sways in this cosmic dance. Most objects in our solar system, including other planets and asteroids, follow similar elliptical orbits. They all dance to the same tune, swaying in and out closer then farther, in a rhythm set by the interplay of gravity and momentum. This elliptical pattern is the norm, not the exception. It's a cosmic waltz played out on a grand scale, a testament to the universal laws of motion and gravity. Even comets, those icy wanderers from the outer reaches of our solar system, trace out long stretched-out ellipses as they swing around the sun. And here's an interesting fact, a perfect circle is just a special kind of ellipse, one where the two focal points coincide. But in the grand scheme of things, perfect circles are the exception, not the rule. The universe, it seems, prefers ellipses. So, while a circular orbit might seem more orderly, the elliptical path is the rule rather than the exception in our solar system. So, to wrap it all up, the intriguing mystery of Earth's elliptical orbit is a delicate dance between the sun's gravitational pull and Earth's initial momentum. This balance is akin to the dynamics of throwing a ball. If you hurl it straight up, it plummets back down. If you toss it forward, it continues moving forward, even as it descends due to gravity. This forward motion mirrors the momentum Earth possessed when it commenced its journey around the sun. A perfectly circular orbit would have demanded a precise starting momentum. If Earth's initial momentum was too weak, we would have been drawn straight into the sun. On the flip side, if it was too strong, Earth would have escaped into the cosmos. Thankfully, Earth's momentum hit a Goldilocks zone, resulting in a mildly elliptical orbit. And we aren't alone in this. Most celestial bodies within our solar system, from other planets to asteroids, trace elliptical orbits. A perfect circle is merely a special type of ellipse. Next time you gaze up at the sky, remember that the elliptical path Earth follows is a testament to the beautifully complex laws of physics that govern our